We are now familiar with parallel lines. What we're going to be looking at this lesson are perpendicular lines. At the end of this lesson, you'll be able to write an equation of a line that is perpendicular to another line. Right, before we start writing equations of lines, let's talk about what perpendicular lines are. Okay, perpendicular lines have slopes. Instead of slopes that are the same as in parallel lines, they're going to have slopes that are opposite reciprocals. And this is the algebra definition of perpendicular lines. Examples of perpendicular lines you'll notice right now on the paper. The x-axis and the y-axis are perpendicular lines. They not only are going to have slopes that are opposite reciprocals, but probably what you learned about perpendicular lines is that they intersect at right angles. So they make a 90-degree angle when they do intersect each other. And if we're looking at the slopes, the slope of the x-axis would be 0, or it could be like 0 over 3, 0 over 2, 0 over 1. And then the slope of the y-axis we know is undefined, but let me just show you how those are opposite reciprocals of each other. If I have 0 over 3, the opposite of 0 over 3 would be negative, and then the reciprocal of 0 over 3 would be 3 over 0. And no, we cannot divide by 0, so it is an undefined slope. So those do have slopes other than just intersecting at right angles. They have slopes that are opposite reciprocals of each other. Another example of two perpendicular lines, if I have a line that's going this way, one that would be perpendicular to it would look just like that. Notice they do intersect, but they intersect at a right angle, so that's what makes them perpendicular. If I was looking at the slopes, let's say I told you that the slope of this line right here is negative 2/3. The slope of this line is going to be positive 3/2, and the reason that if you look at this, the opposite of a negative is a positive, and the reciprocal of 2 over 3 is 3 over 2. And one thing, if you struggle with the word reciprocal, it's just the flip. We're flipping the fraction over. All right, in an example, write equations of two lines that are perpendicular. So this time we don't want a picture, we actually want an equation. Just like I did in the parallel lines video, I'm going to start with the equation y equals 1/2 x plus 3. You can start with whatever equation you want to. It doesn't matter what the slope is, it doesn't matter what the y-intercept is. But now we're going to write an equation that is perpendicular to that one. So the slope of this first line is 1/2. So to make the second one perpendicular, this one is a positive, we need to make this one negative, and 1 over 2, the reciprocal of 1 over 2 would be 2 over 1. And then I have my x still, and then I can have my b be whatever I want. I think this time I'll have it be plus 7. Well, this should be a 1. Sorry about that. I probably confused you. Another way of writing that second equation would just be y equals negative 2x plus 7. You don't have to put the 1 underneath. Right, again, before we start writing equations, I just want to make sure that we're very familiar with slopes of perpendicular lines. So this example, are the two lines perpendicular? And explain. So once again, the question that I'm going to be asking myself, it has to do with their slopes, are the slopes opposite reciprocals? If we can answer yes, then they are perpendicular. If we do not answer yes, then they are not perpendicular. Okay, so line A passes through 5, negative 1, and 7, 8. Line B passes through negative 2, 10, and 7, 12. So we want to find the slope of line A, so I'm going to do my y minus my y. So I'll have negative 1 minus 8, and then over x minus x, I'll have 5 minus 7, leave, change opposite, leave, change opposite. I'll get negative 9 over... Did I do that right? Oh, I wrote that wrong. It says this was a 7. Negative 2, and that reduces to 9 over 2. Okay? And then B, we're finding the slope. Again, I'm going to do y minus y, so 10 minus 12 over negative 2 minus 7, x minus x. Leave, change opposite, leave, change opposite, or use your calculator. We'll get negative 2 over negative 9, and that reduces to 2 nines, because a negative divided by negative is a positive. So are they opposite reciprocals? They definitely are reciprocals of each other, because 9 over 2, if you flip it, is 2 over 9, but they are not opposites because they are both positive. So the answer for this one will be no, and the reasoning would be they are reciprocals, but not opposites. Okay, and now if we look at example 3, line A is y equals 3x minus 1, and line B is x plus 3y equals 5. Again, we want to compare their slopes and answer the question, are the slopes reciprocals? Line A, it's already written in mx plus b form, so the number in front of the x is 3. So we know that the slope of that first line is 3. And then the second one, we're going to have to solve for y so we can find the slope. I'm going to put a 1 in front of the x, so we're going to subtract 1x from both sides. So I will get 3y equals 5 minus 1x, and then to get y by itself, we're going to divide all three parts by the 3, so I'll get y equals 5 divided by 3 does not work out nice, so I'm just going to leave it as a fraction, and then minus 1 divided by 3 does not work out nice either. So this is my answer. The slope is the one in front of the x, so it's the negative 1/3. So this one has a slope of negative 1/3. So I'm going to ask myself the question, are the slopes opposite reciprocals? First of all, one is positive and one is negative, so they are opposites. And are they reciprocals? If I have 3 over 1, the flip of that would be 1 over 3. So yes, they are reciprocals. So yes, and then my reasoning would be they are opposite reciprocals of each other. Okay, now that we have looked at the slopes of perpendicular lines, we're ready to write some equations. So these examples say to write an equation of the line that passes through the point and is perpendicular to the given line. So again, just like I did in the parallel video, I am going to draw a picture for number 4. You do not need to draw this picture, I just need you to watch what I'm drawing. So if I draw the line y equals 5x minus 3, which means we're going to start down at negative 3, and then from there we will go up 5, and then over 1. And then connect them, and then let me draw the point negative 1, 4. Okay, I am looking for a line that is perpendicular to this first line. So perpendicular means it has to cross at a right angle. So it's going to look something like that. So notice it's crossing that line at a right angle. I'm looking for the equation of this line. So that's what I'm looking for, right? That's my goal, all right? From up here, I can tell you that I know my slope of this line is 5, okay? I know that my line is going to pass through the point negative 1, 4. If the slope of the original line is 5, if I'm looking for a perpendicular line, I'm going to take the reciprocal and the opposite. So opposite of 5 would be negative 5. And then the reciprocal, if this is 5 over 1, my slope is going to be 1 over 5. All right, and now I am ready to actually find the equations because I have all my information. Let's label this x and y. Y equals mx plus b. So notice as soon as you figure out your slope, it's like problems we've been doing for the past week. All right, y equals 4, m equals negative 1/5, x is negative 1. So I'm going to get 4 equals negative 1/5 times negative 1 is 1/5 plus b. To get rid of the 1/5, I'll subtract 1/5 from both sides. 4 minus 1/5 will be 3 4/5. So the equation of my line, I'm going to come right up here and write it. Y equals my slope, my new slope is negative 1/5 x plus the b, plus 3 4/5. So that would be the equation of this line right here. Okay, number 5, I won't draw the line this time. The point goes through negative 2, the line goes through the point to negative 3. It's perpendicular to y equals negative 2/3 x plus 7. So what we are going to do, we know y equals negative 2/3 x, the m is the negative 2/3. So my new slope is going to be the opposite of that, which will be positive, and the reciprocal of 2/3 is 3 over 2. So that's my new slope, and again, I know it's going to go through the point to negative 3. So now, if I even want to, I might even scribble out that problem, because here is my new problem. Okay, so xy, y equals mx plus b. My y is negative 3, my m is 3/2, my x is 2 plus b. And now we have negative 3 equals 3/2 times 2 is 3. And then I'll subtract 3 from both sides. It's not 0. Negative 3 minus 3 is negative 6. So the equation of my line will be y equals, my slope is 3/2 x, and then minus 6. So that's the equation of the line that was perpendicular to that one that I scribbled out. Okay, number 6, you know what's going to happen on this one. It is your turn. So please pause the video, give it a whirl, come back and see how you did. Okay, hopefully you're back because you have an equation. What we are going to do on this one again is we need to get the slope from the y equals negative 3x plus 4. So my slope is going to be the negative 3. So my new slope is going to be the opposite of negative, which will be positive, and the reciprocal of 3 over 1 would be 1 over 3. And then my point, it's going to go through 5, 7. And again, if you want to scribble that off so you don't accidentally use it, that is a good idea. Okay, x, y equals mx plus b. My y is 7, my m is 1/3, my x is 5 plus b. So then I have 7 equals 1/3 times 5 is 2 2/3 plus b. I will subtract 2 2/3 from both sides, and again, fraction buttons are great for this. We'll get b equals 7 minus 2 2/3 is 4 1/3. So now we just put the equation together. Y equals m, which was 1/3 x plus 4 and 1/3. So that's the equation of the line that's perpendicular to the line that I scribbled off. So hopefully now you can write an equation of a line that is perpendicular to another line.